Good. People, let us look at one of the section in trigonometry which sometimes need an extra thinking. Is proving whether the two sides of an expression, a trigonometric expression, equal, né? Using the fundamental identities. Né? Now, people, I'm giving you this well, I'll put extra points to make your life easy here. All right. In this case, people, you need to choose. Okay? You need to choose the more complicated side. You choose the more complicated side. By the way, you'll be given the two sides. Look at the complicated side. Can I say in our language we might also use difficult instead of complicated? We might say choose the most difficult side. Try and manipulate. Manipulate is just to simplify. Ne? Manipulate is to simplify. Simplify that side to look exactly the same as the other side. However, both sides may be manipulated if it suits you better, particularly if both sides are complicated. Okay. Secondly, people, use any of the fundamental identities. Right? Use any of the fundamental identities. Ne? In your manipulation, in your simplification, use any fundamental identity. It is important, people, to know them very well. I said to you, people, it is very important to know the fundamental identities so that you can select the right one for each particular problem. If no other alternative approach, né? If you can't suggest any approach, express the function in terms of sine and cos. People. Well, in my classes, normally I said, first of all, change everything into sine and cos. First of all, change everything into sine and cos. But later on, my learners used to take this route and this route. And I believe people, let's take this and make it number one. For now, when you are now familiar with everything, is then you can take this one as number one. But for now, change everything into sine and cos, and you start to see it. If it suits you, you can start with this, you can start with that, and so on. Let's take, for example, is everything is now in sine and cos, né? And you can't continue. Is then you must apply the fundamental identities. Alright? Since you have been asked to prove one expression identical Do you remember identical twins? Since you have been asked to prove one expression identical to another, it is preferable not to move a term from left hand side to the right hand side or vice versa. Each side should be manipulated independently of the other until they are the same. Symbol for symbol. Symbol for symbol. People. Now, people, I just want to add. Can I add something? I'm adding number 5, but I'll write number 5 here, people. Let me write number 5 here. Add or subtract. Add or subtract. I'm sorry. Right. Add or subtract. Let me. Oh my God. Add or subtract. The fractions by using denominator. Denominator. Add or subtract fraction by using denominator. You may require to take out a common factor in order to simplify an expression. If that might be, you can do so. I just want to take you through one or two problems. I need a space here, people. I'm taking exercise 7.2 number 2A. All right, number 2A. Okay, look at this one. It says we should prove that the tan of theta multiplied by the cos of theta equals to the sine of theta. People, we are having this one. We call this one left hand side. We call this one right hand side. Ne? Which one is the complicated side? The difficult one. I hope you can choose the left hand side. Left hand side is our complicated side, which is tan theta multiplied by cos theta. People, I said to you, change everything into sine and cos. Let's change this one into quotient identity. You remember? Sine of theta divided by cos of theta. Immediately, people, you can see that the cos divide the cos, okay, and you are now left with sine theta. And this makes the left hand side to be the same as the right hand side. Easy. Follow that procedure I gave it to you. Follow that procedure I gave it to you. Put that procedure in your bedroom. Every time when you wake up, you look at this one. Change everything into sine and cos. Apply the fundamental identities. Manipulate the complicated side. Then be used to this. Okay, let me take another one. Maybe any of okay. Let me take on the same exercise 7.2 number 2. Let me take which one? Let me take C. Right? C. In the clever mathematics, all right, it states that the cos squared x, all right, plus the cos squared x multiplied by the tan squared x equals to 1. Okay. The mere look of the eye, people, we can identify that the left hand side is the complicated side. Left hand side, which is cos squared x plus cos squared x tan squared x. People, just by inspection, we can take a common factor here. Just by inspection. 1 plus tan squared x. Alright, people. Do you remember the square identities very well? Do you remember the square identities very well? Can you tell me what is this? Huh? People, this is sec square x. People, can you change everything into sine and cos here? This one is already cos. This one you can change it to 1 over cos squared. There you go, people. There you go. This is equals to 1. I'm telling you. You proved that the left hand side is the same as the right hand side. That's the way of manipulating. People, go through question exercise 7.2 number 2 and number 3. Do as many problems as you can, people. If we have time, we will therefore prove any of these problems. You can say, no, let's try this one, let's not try this one. Any of these problems. Okay, let's see in the next slide. We'll be doing reduction formulae. Okay, good.